All right, welcome back to Mr. P.L.'s with Algebra. This is Unit 4, Topic 2, Lesson number 8, which we're going to be dealing with special polynomials, which means that I know you're working with area models quite a bit. We're going to be working with ones that are perfect squares. They're either differences of squares or they're exactly perfect squares. All right, so we got to warm up here with multiplying, so we use the FOIL method. First, outers, inners, last. First gives you x squared, outers gives you negative 9x, inners gives you negative 7x, and last gives you positive 63. Once you simplify the two middle terms, you get x squared minus 16x plus 63. And there you go, standard form. Vector form turned into standard form. Same thing goes here. First, outer, inner, last. Gives you x squared plus 3x plus 8x plus 24. Now, some of you might be noticing, because I know we've done a lot with this, that really the middle term ends up being the two numbers combined, and the last term always is the two numbers multiplied. Now, that only works if there isn't a leading coefficient, meaning there is no a term in your standard form. 8 plus 3 makes 11x, and then your c term, just bring it straight down, is 24. Now, notice that there are leading coefficients this time, so we're actually going to solve this through. So that's going to give you 6x squared. This is going to be 2x. Inners is going to give you negative 15x. And last is going to give you negative 5. Simplify your two middle terms. So your answer is 6x squared minus 13x minus 5. All right, so now down here we got standard form. We're going to change it to factored form by factoring it. No leading coefficient, so what gives you negative 28 and also adds up to negative 3? So what I like to do is write out all the factors of 28. 1 times 28, and that's not going to be it. Keep in mind it's a negative, so one of the terms is going to have to be negative. 2 times 14 is not going to give me negative 3. Does 3 go into 28? 3 times, let's see, 7, 3 times 8 be 24, 3 times 9 be 27. Nope, sure doesn't. Does 4 go into 28? So 4 times 6 is 24, 4 times 7 is 28, so there it is. And that happens to be the number that we are looking for. So we know the answer is going to be x minus 7 times x plus 4. Now keep in mind, it has to be the 7 that's negative, because these two terms have to add up to negative 3. And if the 7 was the positive and the 4 was the negative, then it wouldn't add up to negative 3, it would add up to positive 3. So this is the only way. Now you can reverse the two factors. You can flip the 2 and change the parentheses around, but you cannot change the signs. All right, same thing here. So we got factors of 24 that add up to negative 10. So that's going to be, let's see, it's not going to be 12 and 2. It's going to be 6 and 4. And it's going to be negative. So it's going to be x minus 6 and x minus 4. If you multiply those two numbers, you do get positive 24, and you add them, you get negative 10. Number 6. Now you've got a leading coefficient. 3 times negative 2 is negative 6. Find all the factors of 6, and there we go. Keep in mind that it is negative, meaning one of the two terms has to be a negative as well. And it looks like it's going to be 6 and 1. So I'm going to split that middle term into 6x minus 1x. Bring this down. 3x squared. Split it in half. Factor out the GCF on both sides. This side's going to turn into x plus 2. Factor out these can both be divided by 3x, and that leaves me with x plus 2. So the answer is 3x minus 1 times x plus 2. All right, so there we go for the warm-up. So we did a little bit of factoring and FOIL method to change standard into factored form. Like I said before, we're going to be doing everything in this video is about specials. Special, and that happens to be all, not just rectangles, but they happen to be squares, which are, yes, our special type of rectangle. So if I was going to turn this into a area block, that would give me x plus 3, so we got 3 longs one way and 3 red longs the other direction. You're going to end up with 1 blue flat. The two sets of longs are going to cancel each other out, and you're going to be left with 9 little units, 9 little red units. In this one, if you're going to make it with 3 green tiles, 3 green longs in both directions, you're going to end up with x squared plus 6x plus 9. And if you do 3 red longs going in both directions, once again, still a square. So once again, so this is flat, so you got 1, 2, 3 longs here, 3 longs here, and you would end up having to put 9 little units right there to complete the square. So that's x squared minus 6x plus 9. What do you notice and wonder about the area of each block? Well, what you should notice, well, When you got a differences of squares, meaning one's positive, one's negative, it ends up with a binomial answer. And it's always got to be a negative right here in order for it to work. You can just add these two terms, get this, and multiply them, get here. Add them here, multiply there, and it works out. All right, so same thing goes for these top three questions right here. So the area of this square is going to be x squared, like we just learned a second ago. Differences of squares, because one's positive, one's negative, they cancel. So it's going to be x squared minus 16. This one's going to be x squared plus 8x plus 16. Once again, 4 plus 4, 4 times 4. And the last but not least, we got x squared minus 8x plus 16. Now, what you might notice about question number 4 is that these look a little bit different. And what makes them different is that it has a leading coefficient. So really, this is differences of squares. This is going to be 25x squared. I got that because I did first and FOIL. And now I'm just going to go straight to last, when 1 times negative 1 is negative 1. And I'm doing that because whatever I get for the outers and the inners, since it's a perfect square, are going to cancel each other out. Negative 5x, positive 5x. Now this time it's not going to cancel each other out. So you're going to get 25x squared. Outers would give you 5x. Inners would also give you 5x. So basically you're just multiplying the two terms and doubling it. So that gives you 10x. And then multiply your last gives you plus 1. All right. And last but not least, it's going to be the exact same answer, but with outers is going to be negative 10x. And inners, I'm sorry, outers is going to be negative 5x. The inners is going to be negative 5x, which makes negative 10x. And then you still got plus 1 at the end. All right, so what have you noticed about the patterns? Have you been able to calculate what goes on? So in this case, you're really just multiplying a times a, and then you're subtracting b times b. So b times b would be b squared. So it's just like that. So for this one, you are multiplying a times a, which is a squared, plus 2 times ab. So when you multiply a times b, which is outers and inners, you're doubling because the outers and inners are both exactly the same. And then last, b times b makes b squared. So that's really the format that you use when it's both positive. And when they're both negative, it's going to be the exact same thing, only it's going to be minus 2ab, because you notice that the middle term was always negative, plus b squared. All right, so there we go. So you can see exactly what's going on for all these questions. Now, what if we want to factor it? So how can we use that to our advantage? Well, first of all, I know a is going to be a differences of squares because it's a binomial answer. So this is going to be an x minus 2 square. And I know this because x times x is x squared, and negative 2 times negative 2, I'm sorry, negative 2 times negative 2. Oh, it's differences of squares. Okay, I knew something wasn't working out. So it's x plus 2 times x minus 2. All right, this one's also going to be differences of squares. It's going to be x plus 7 times x minus 7. Almost did that again. Try that. There we go. So 7 times negative 7, x times x is x squared. Now the outers and inners are going to cancel each other out. Don't forget that. So do the square root of both these numbers, and that's basically where you're getting your two terms from. So this is going to be 2x minus 3 times 2x plus 3. 2x is the square root of 4x squared, and 3 is the square root of 9. All right, so part B over here, I'm going to go straight down again for this row as well. So this is going to be an x plus 2 perfect square. Notice that you're doubling this number and putting it in the middle, and you're multiplying it by itself to get this. This is going to be an x minus 2 square, also a perfect square as well. Plus itself times itself. This is going to be an x plus 7 square, plus itself times itself. This is going to be an x minus 7 square, plus itself times itself. All right, now this one gets a little bit trickier because, yes, we do have that leading coefficient. This is going to be a perfect square again. It's going to be a perfect square of 2x. That's the square root of this. So I'm really doing the square root of both the a term and the c term. It's going to be a 2x plus 3 square. 2x plus 3 times 2x plus 3 equals this. Now, remember what we learned, let me go back a page, that the middle term was always double a times b. Well, in this case, a is 2x, b is 3. That will give you 6x. Double it does give you 12x. Check. That does work. All right, so this is going to be a perfect square of 2x minus 3. And the only reason you can tell the difference between this and this is the b term. If the b term is negative, it's going to be a negative. If the b term is positive, it's going to be a positive right there. All right, looks like we're ready for the homework. Differences of squares. Okay, so we just did a lot of practice on that. So this is going to be an x minus 3 square times itself plus itself. This is going to be differences of squares. This is an x minus 9 times x plus 9. Differences of squares, perfect square, but you have red and green longs in both directions. This is going to be an x plus 8 square. And I know that because 8 times itself, 8 plus itself. This one's also going to be differences of squares. This is going to be a difference of 3x minus 5. Now, if you're wondering where did I get those numbers, I did the square root of both the first term and the last term, the constant and the leading coefficient of the x squared. So what times itself is 9? 3. 3x times itself is 9x squared. What times itself is 25? Well, that's 5, and since it's a negative, if this was a plus here in the middle, this would be prime. It would be not factorable. It has to be, for a binomial, for special to be work, it has to be red units. It has to be minus. If it was plus, it's not going to be able, you're not going to be able to do anything. All right, so this one, first thing I notice right away is that all 3 of these terms can all be divided by 3. So always look for that first. That makes the problem a lot easier. That makes this, whoops, no, the 3's on the outside. 3 times x squared is 3x squared, and 3 times 2x is 6x, and 3 times 1 is 3. All right, so I factored out that GCF. So I got myself a distributed property. I'm going to leave the 3 on the outside. All right, so that's one of the factors on the outside, and I'm going to factor what's on the inside. What 2 numbers give me 1 when you multiply them, but also add up to 2? Well, that would be x plus 1. So that's a perfect square of x plus 1. Times itself plus itself. Perfect. There we go. All right, last one. We have no common factor here. We're looking for what 2 numbers give you 121, but also add up to negative 22. That's a perfect square of x minus 11. 11 times itself, 11 plus itself, and it's got to be minus because the b term was minus. All right, great. Please understand before I sign off on this video that this is basically a cheating method. I'm not going to say cheating, but it's not really. It's a shortcut. It's a shortcut way of doing special rectangles. And it's, when I say special rectangles, it happens to be only rectangles that are squares. These methods are only working when you have area models that are squares. All right, please give it a like always if I helped you learn something in this video, and subscribe if you haven't done so already. Have a wonderful day. Thanks for watching.